All right, so more than just shapes. So yeah, you can be like, oh, I know what all those shapes are.
I'll let you know. We're going virtual.
Yeah, that's like what you think of right now, right? I think we're okay. Actually, our numbers rate, I feel like attendance has been better than it's been in a while. So, all right, the reason these shapes are up here is, yeah, we're talking about shapes. These are all different types of polygons. Now, the ones that are drawn up here are all called regular polygons. So that means all the sides and angles are equal. So all of these are kind of like, if I were to go into a kindergarten class and say, what do they picture a triangle looking like? They would picture this triangle. Although we've known that there's, there's other types of triangles, like acute, obtuse, right, like those are also triangles. Same thing like a four-sided shape, obviously there's other four-sided shapes. This happens to be a square. Kind of same idea with all of these, a pentagon, all the different shapes. These are like specific, like they're kind of your perfect pentagon. All the sides, all the angles are equal. I could draw a pentagon on the board and it would not look as perfect as that one. So these are all considered regular polygons, and we'll talk about that in a little bit. So we're going to talk about the angle measures of the interior of these shapes today. So hopefully the triangle you already know. So talking about the angle measures of shapes. So polygons are made up of triangles, and that's kind of a weird statement to say. So polygons are made up of triangles. And I'll show you what I mean by that in a few minutes here. So starting with a polygon, the smallest number of sides we can have for a polygon is 3. Because if you only have 2 sides, then it's not a shape, just 2 lines or, it's just not a shape. So 3 sides are the smallest number of sides we can have for a polygon because it's an enclosed shape then. And obviously that type of polygon is called a triangle. Now all types of triangles are included in this rule. So right, acute, obtuse, scalene, isosceles, all the different types of triangles. Now in a triangle, we're going to say that there's one triangle. And what do I know about the sum of the interior angles of a triangle? They add up to 180. So it's 180 degrees if I add up the interior angles. So that's not new information to you. However, we're going to talk about how that relates to the rest of these shapes, because all shapes can be made up of triangles as we do these. So the next one we're going to do is 4 sides. Does anyone know the really general name for a 4-sided shape? Square is specific. It's a specific type. Just like you guys are...
Quadrilateral.
It is. It's a quadrilateral. It's close.
Never mind. Pretty much correct.
So quadrilateral. So yeah, you guys might say a square, a rectangle, even a trapezoid. There's lots of shapes that have 4 sides. The most general one is a quadrilateral. Just like you guys are all students, but then I can be more specific. There's freshmen, sophomores, juniors, seniors. There's male, female. There's athletes. There's different types of students in here. Just like there's different types of quadrilaterals. Now, I'm gonna flip back to so in our quadrilaterals, our square, I can break a square up into 2 triangles. So I can draw that, and it's made up of 2 triangles. Now you could draw a whole bunch of triangles in here. I know, like you could keep drawing lines. We kind of want to draw the bare minimum. So there's 2 triangles. If there's 2 triangles in our square or in our quadrilateral, what's the sum of the angle measures going to be? 360, because there's 2 triangles in it. There's 180 in one triangle, and 2, there's 360. So 360 degrees. And you might know that just because The sum of the angle, like if this is a square, all the angles should be what? In a square, they're all 90. If these are all 90, 90 times 4 is 360. So that might be one you might know already, just because of what you know about shapes. The next one after that is going to be 5. What's the name of a 5-sided shape? I already said this one.
Pentagon.
Pentagon. Holy cow, Michael's our shape expert. Pentagon. This is the one that maybe might remind you of the building in Washington, D.C. is one of the buildings that was attacked in 9/11 was the Pentagon, and it actually is shaped like a 5-sided structure. So how many triangles, what's the minimum number of triangles I can use? Yep, I think 4. Can anyone do less than 4?
3.
3, I think we can do 3. So if I go down and then down again, it's 1, 2, 3. And those 3 triangles make up that shape. Now you can do 4. We want to do the least number because it's going to be a little bit more accurate, or it will be more accurate. So if there's 3 triangles, I have to do 3 times 180. What's 3 times 180? Or add these together.
540.
540.
Oh my gosh.
I know.
It's like 2, 3 points.
It was all because of the awesome game last night.
I was hot from 3-point last night.
Did you really? You had,
Yeah, I went off.
The guy get his first 3.
Were you 1 for 1?
No. Was up for one, but
Oh wait, you took your first 3?
yeah, I airballed it pretty bad, but
But we're gonna say he made it. It makes the game sound better.
I had a wide open 3. I don't know. Yep. All right. So I want to talk about now. There's kind of hopefully a pattern you're kind of starting to see here. So the number of sides. So the next one is obviously going to be 6 sides. What's that name? You know?
hexagon.
Hexagon. So hexagon is a 6-sided figure. Do you see a pattern? How many triangles do you think?
4.
4. So this is going up by 1, just as that one goes up by 1. And again, if you're unsure, if you're like, oh, I don't know, see if we can draw 4. Like here, here, and then one more that way. So that's 1, 2, 3, 4. There's probably lots of ways you could do 4. Not like that. Sorry. So 4 is 4 works there. And once you guys realize this, we won't have to do this chart. Hopefully, I'm going to show you guys that there's actually a rule we can use. So 4 times 180 is going to be 720. So the way I'm getting this is 1 times 180 is 180. 2 times 180 is 360. 3 times 180 is 540. 4 times 180 is 720. So let's talk about in general. So the next thing we're going to talk about is an n-gon. So sometimes the book will do this, or we'll just do this, is that at some point we want to stop having to know all these names. It's like a 13-sided shape, for you to know the name of the 13-sided shape is not all that important to me. So we can just call it an n-gon. The n is the number of sides. So that number of sides can be anything. So again, if it's 13 or if it's 28, whatever the number of sides it is, how would I find the number of triangles? How would I get this value from that? You subtract 2. So this would just be n minus 2 because this is 5 minus 2 is 3. 6 minus 2 is 4. This pattern is holding true, and you could check it on other ones as well. So then how would I find the sum of the angle measures?
N minus 2 times 180.
Very good.
Times what?
180. So 180 times n minus 2 is how we got that number. So we took the number of sides, subtracted 2, and multiplied by 180. formula is one we're going to use quite a bit this chapter. So this is actually a formula we kind of developed from our chart here. So it's kind of nice when you guys can say the formula without me just having to say this is our formula. It's like logical that it kind of comes out of that. So it says find the sum of the interior angles for a decagon, which is a 10-sided shape. So again, I'll try to give you guys like the name of the shape and like how many sides. If you ever have to Google it, feel free. Don't feel like you can't look that up. So the sum of the interior angles for a decagon, which is the 10-sided shape. So now you could try and draw a decagon and try to draw the triangles. I don't think I have a decagon on the top. No. A decagon's pretty hard to draw freehand. I have these little cheaters here. So it almost starts looking like a circle if you probably try to draw it. So a 10-sided shape. So trying to draw all the triangles in there would be a big pain. It basically is there should be 8 triangles in there. And so I can keep drawing these. So there would be 8 triangles. So again, we can use our formula to help us with that. That's 180 times n minus 2. The number of sides is 10. So 180 times 10 minus 2. So 180 times 8. And that's going to give us our sum of our interior angles, bless you, which is 1,440. And that kind of makes sense because these angles are pretty big angles. They're pretty stretched out. And that's for any 10-sided shape. All right, so let's flip to the back side. It asks us to find the measure of each angle. Now, if you notice, the opposite angles are equal. Like this equals that, this equals that. I'm going to give you guys a heads up. My drawing's really bad. Like, so what looks acute might be obtuse. What looks obtuse might be acute. Sorry, bad drawing. And that probably makes sense because if this is 5x and that's 11x plus 4, you already could probably tell the drawing's bad. So the opposite angles are equal. But don't let that, because that really won't help you. If I set those opposite angles equal to each other, they just cancel out. But what do I know about the sum of the angles of this shape? It adds up to 360. This is a 4-sided shape. So that means the sum of the interior angles would add to 360. Either based off our chart or based off our formula that I can do n minus 2 times 180. 360 is going to be one of the ones you're going to want to just know. You don't want it, we're going to use that one a ton. So hopefully that's one you're just going to be comfortable with and be able to just know. How would I be able to figure out what the measures of the angles are then? Yeah, what do you think, Michael?
Couldn't you just do like 5x plus 11x plus 4 equals 180?
Yeah, so what he was suggesting, rather than having to say, let's add them all up to equal 360, he knows that the opposite ones are the same, so he's saying, why don't we just add up the 2 of them and have them equal 180? That would also work. If you didn't notice that, you could add them all up and have them equal 360. Either way is fine. You'll get the same answer. I'm probably going to stick with the 360, even though that's longer, just so that, because this is probably what most of you would think, but the 180 does work if you only do 2 of them. So if I put these all together, I have 5, 5, 11, 11. So I get 32x. And then I have 4 and 4, so that's going to be 8. And we want to get that x alone. So now we're just going to subtract 8. then we'll divide by 32. And find out x is 11. Now again, here's where you find out my drawing is really horrible. You go to put that back in to check these angles. So 5 times 11, 55. So that's obviously looks like an obtuse angle, and it's not, but it's bad drawing. Same thing opposite over here. And then I can do 11 times 11 plus 4. So 125. Okay. All right. Why don't we stop and grab whiteboards for a little bit and do a little bit of practice with this. So if, like this half of the room wants to grab them.
Luke, you grab one.
Yeah.
Once you get your board, you should draw your favorite holiday character or thing you draw, snowman, Grinch, whatever. Dragon.
Dragon.
Other half of the room you guys want to grab?
You don't want to draw. Do it. To what? It's because you're here. For what? Grab them. Is that what, go see it. No.
What is that?
What else was on the list?
Arms.
You know, right. That's what it is. What else? What is it? Yes. What reindeer? Can you hand judge me? It's Vixen. You know, he heard his flips come on small.
Okay, what do you guys got? Any good drawings out there for me?
What is that?
Oh, snowman.
What is Corin?
How did you guys see the Grim?
This is the Grinch.
How did you see
Rudolph.
Rudolph.
Looks like a dog.
Oh, is that the dog from the Grinch?
No. How do you see a Grinch on that? It's messy.
Here, can we do another one?
Okay, look at them up. Don't you remember one is
When he smiles real big, yeah.
Yeah.
No.
I didn't know what his eyes looked like though.
Because Christmas Eve.
I need a black one.
It's real
Why
white.
take pictures? I need black.
That's why.
It looks like a Grinch. I mean, I don't think he's supposed to have a nose.
He has like a snout thing.
Yeah, you gotta pick
Like
them.
kind of a beak, right?
And I used to go get the carrots, the arms.
Do like a 6 or a 7.
Oh, I know.
Or a no.
And then
Or
that's
a
why. That's why
I like
Like
that.
the upside down.
You have the Grim Reaper back there?
then it's like a bottle
How could you not guess that?
That's why.
How could you guess that? That looks like.
It's green.
What was the movie? It was like.
Like little pleasant.
It was like the Christmas and Halloween. Or the guy. Yeah.
Nightmare Before Christmas.
Yeah, Nightmare, it looks like a movie from Nightmare Before Christmas.
It looks like trash.
No, that was,
But
no,
what does it look like?
the mayor from Nightmare Before Christmas.
It's
Reverse.
look at that smile. You don't remember when he smiles like that in the movie? Exactly. You remember it. Because I don't know what his eyes look like. I haven't seen a shrink since last year. Don't judge me. I don't know. I don't know what it looks like.
Okay, guys, we're gonna find the value of x. We're gonna find the value of x based off this shape.
Let's see it.
Hang on a second, I have to do it.
I need a. Oh my god.
Yes. How'd you fix that? Yes. So you have to figure out how many sides are on the shape. Then you have to figure out what it should add up to, yep. Yes. Yes, good job.
That looks exactly like Kyle's socks last night.
Erase
Yes.
it.
No, he's staying on the board forever.
He can answer the questions.
He knows them.
Yes. Yes.
Hold on.
Yes. Yes.
Okay, that we have to,
Yes, that's it. Yep.
what's the movie about?
Yeah, the yellow, yeah.
What's the movie about? And what?
Okay, so guys,
I think we're watching.
I'll give you guys a little trick. The number of sides and the number of angles are the same amount. So you can count the number of angles and see it's 1, 2, 3, 4, 5 angles. So that means it's also 5 sides. So if this is 5 sides, you can either look at your chart or you can do 180 times n minus 2. So 180 times 3, because 5 minus 2, there's 5 angles. So this is 540 total. So these all together should add up to 540. So the missing piece, the leftover, would be 90. So this would have to be 90 as well. And it might not look like 90, but just go with it that it should be. All right, let's do another one here. Some of these are kind of hard to draw too. Let me give you the angle, sorry. That should be an angle there too, clearly. So again, find the value of x. Good job. I have to try and beat you guys because I have an answer key. Need a new marker. Yes.
I think it
So you have to find out the number of angles there are. Yes. And then you're gonna have to, yeah. Good job, Grinch. Yes. Yes.
Yeah.
You don't have to share Kleenex.
Are you doing that on the test?
I need
There you go.
Yes. Yes.
You brought me a dried out water.
So, how many angles are there? Seven. So you have to do 7 minus 2. And then multiply by 180, and I'll tell you the sum. That's going to give you the total.
What?
And then you have to take all the rest of these away. I think you might have
Yes, it
missed
is.
something or done some math wrong. You're really close, but not quite. Yes,
It is
yes.
different.
I think you're missing. Oh, don't forget that one's 90. I think you're missing the 90.
Oh,
Yeah. 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 So that right angle
I don't feel like
corner is 90. So
or red
Or vegetable.
Grinch or carrot.
French or vegetable.
Grinch or green bean. All right. So there should be 7 angles. There, you got it. So there should be 7 angles. So this time I had to do 180 times 7 minus 2. So 180 times 5, which is 900. So that tells me the sum of all these angles. And then I have to solve that by using, by taking those away. So the biggest thing I think is remembering this one has to be 90 then. Yes. Yeah, Riley, you're good. Yes, good job. Yes, good job. Yes. 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 You have to, there's 2 X's. So you have to find one of the X's. If you found 2. Not quite. Are you gonna figure it out? And then there should be, there's 2 X's. I don't know if that's what you're, there we go, that's it. Did you say mine's wrong? No, you're good, sorry.
Oh, okay.
Sorry. Yes, good job. Yes. Yes, good job. All right, so this one, you guys, is another 5-sided figure. So it's 540. But this time we take all these little pieces away and we end up with 232. But that's what these 2 X's have to equal. So we have to divide that by 2 to figure out that one of the X would be 116. Let's see. All right, why don't you hang on to your boards, but just set them aside for a second.
Actually, one second. So, I mentioned this regular polygon thing before, was the idea that basically you go into a kindergarten classroom and ask them to point out a triangle to you, they would probably choose the regular polygon. And that's the all equal sides, all equal angles. So a regular polygon is all equal sides and all equal angles. So when you first learn a shape, someone probably draws the most basic version, and so that's an equilateral. So all equal sides, all equal angles. So this would be considered a regular polygon, is an equilateral triangle. Whereas a 30, 60, 90 would not be. Or a square is a regular polygon. All equal sides, all equal angles. Whereas a rectangle is not. It has all equal angles, but not all equal sides. So just understanding it's kind of your most straightforward, kind of most recognizable version of whatever shape that happens to be. Now there's also two types of shapes you can have that are called convex and concave. The one you're probably going to be most comfortable with is convex, because that's what we typically draw a shape as. So convex is all the angles are less than 180 degrees. So just like a normal polygon, what you're used to seeing. What a concave is basically it looks like they took a side and they kicked it in. So it's kind of, I mean, like again, if I went into like by the elementary school and said, is this a quadrilateral? They might not think so, or is this a pentagon? So this is an example of a concave pentagon. It's still a pentagon. Sounds like I made up a new name. It's still a pentagon, but it's kind of a weird looking one because this angle is more than 180 degrees. If I wanted to know that angle, it would be more than 180 degrees. So it's kind of a weird pentagon. You don't see these as often just because they're kind of a strange shape, but it's still a pentagon. That's a concave, and then obviously convex would be just our normal pentagon. All right, so then this next part, and this is what we'll still practice a little bit more with our whiteboards before we move on, is it says the measure of an interior angle of a regular pentagon, or a regular polygon, not pentagon, is 150 degrees. Find the number of sides for the polygon. So we have some shape, we don't know what it is. So polygon just means we don't know. So how many sides, we don't know. So the number of sides is unknown. But they tell me one of the angles is 150 degrees. It's the first time you get to see your drawing, right? They draw a little person. Kind of happy. Thanks. Oh, yeah. And then I can fill you in with the rest of it too. Okay. So one of the angles is 150 degrees. We want to know how many sides it has. Any thoughts on how to do this? So if I know if I'm looking for the number of sides, what's that also the same as? number of sides is the same as the number of angles as well. So the number of sides is also the number of angles. Now, if one of the angles is 150 degrees, and I know it's a regular polygon, what do I know about all the angles? What is true about a regular polygon? We just said it right up here. They're all equal. So all the angles are going to be 150 degrees. So if one's 150 degrees, all of them are 150 degrees. I don't know how many there are, but I know there's n of them. So if there's 3 of them, we do 3 times 150. If there's 4, we do 4 times 150. So I'm going to write this as 150 n. That's the sum of however many there's going to be. But I know something else about the sum of the interior angles of a polygon. What else do we know? We have something else other than, we have other information they just taught us. What do I know about the sum of the interior angles of a polygon? Do we have a formula for that? We do. What's our formula we just learned? Yeah. So 180 times n minus 2. The n we're talking about here is the same. So we can figure out the number of sides and the number of angles based off the fact that we know one of them is 150, because all of them should be 150. This only works for a regular polygon. Do you guys know how to solve something like this? What do you want to do? Distribute, yeah, get rid of those parentheses. Okay. Once we have that, what are we going to do next? Minus 180. And for that, how to get that n alone? Divide by negative 30. So negative 360 divided by negative 30. Our number of sides is going to be 12. So that means all the sides and angles are, or there's 12 sides and angles. All the angles would be 150 degrees in this case. All right, let me do one more quick example before we do a little bit with whiteboards. What if I want, so just another quick example, the measure of one interior angle I want the measure of one interior angle of a regular hexagon. Hi. How are you? The measure of one interior angle of a regular hexagon. Okay. What do I know about the hexagon? Let's break this down a little bit. 6 sides. Now a regular hexagon means all the sides and angles are equal. So it's a regular, all the sides and angles are equal. So what we got going on here looks something like this. All equal sides and all equal angles. You don't have to draw it, but they want just one angle. What do I know about all the angles? They add up to what? 720. We know that from either from our chart, or you could do that 180 times 6 minus 2, 180 times 4, so it's going to be 720 That's the sum of all of them. So what would the measure of one of them be? Yeah, you're going to divide it by 6 because we know there's 6 of them and they're all supposed to be equal. So if there's all of them should add 720, so just one of them, we're going to take 720 and divide it by 6, which gives us 120. So each of the interior angles would be 120 degrees. Okay? So grab your boards again. We'll practice this a little bit. All right. All right. So it's called a nonagon, but I'll just call it a 9-gon. A regular 9-gon. I want to know the measure of one angle of a regular 9-gon. Yes, good job. Speedy, yes, good job. Yes, yes. Yes, good job. So the measure of one angle of a regular 9-gon. Yep, yep, yep. So you have to figure out all of them. And then you have to figure out what just one would be. So there's 9 of them, and they're all the same. Yes, good job. Yep, yep. Yes. Yeah. So we know there has to be 9 sides. So we're going to do 9 minus 2 times 180. That's going to give me the sum of the interior angles of our 9-gon. That's 1,260 for all the angles. Now, if it's regular, that means they're all equal. So if there's 9 sides, there's 9 angles. So we're going to take those total and then divide them by 9. Each of them should be 9, and that gives us 140 degrees for each of them. Okay? Hang on a second. Oops, shoot. Hang on. Okay, so the next one, so the measure of one angle is 160 degrees of a regular polygon. How many sides does it have? This is like the example we did just before. So go up like example 3. This is really similar to example 3. So how many sides does it have? If the one angle is 160, this is the one you have to kind of set up a little equation for. We don't know the number of sides. We don't know the total. We just know one of them. Very good. And hopefully the number of sides work out to be a nice number. Because it'd be weird if a number of sides was a decimal. So we're setting up that equation like we did in example 3.
good job. Yes, yes. Yes, good job. Yep, you got it. Set up, in case you're waiting, I'm gonna set up the equation. We know one of the angles is 160, so that means all of them are 160. Yep, yep. So you're gonna solve this equation if you haven't written that out yet. Yes, good job. Have you guys ever forgotten to take your mask down when you go to drink?
I almost would have done it.
No, I was at work and I was stealing another chicken nugget and I dipped it in my buffalo sauce and I went to eat it.
You just shoved it in your
Mask.
mask.
Ah,
Something must have gone.
So then they were like, Michael, why are you buffalo?
So you
So,
said,
Michael, I'm missing a chicken nugget.
not me. You're like the cat that ate the canary that's like, there's like a feather hanging out of your mouth. Like, that's what you're talking about. So, again guys, if you know one of the angles, all of the angles should be the same. So if there's one angle that's 160, all of them are 160. So then when I go to solve this, I find out that the number of sides is 18. You guys, oh, I shouldn't have moved the n over, sorry. You guys want one more? Actually, are you guys feeling okay about them? Can we finish up our notes? No. Now that Tyler just picked up the whiteboard. We want one more? Let's do one more. All right. What's the other type here? So let's find the measure of one interior angle of a regular, I don't think we did this one yet, 17 gun. I don't know the name of the 17 gun. This might be a decimal this time. It's okay for an angle to be a decimal. There you go. Yep. Yep.
you want us to round?
Yep. Yeah, around like one decimal place is fine. Yes. I saw it before you dropped it. Yes, 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 yes. Good job, guys. Yes. Yes. Riley, this is the easier one.
Easier.
So you're making it way harder, yes. So you know the number of sides already, so you can just put that into the formula.
Oh,
Now that we do the
yeah.
total, and then there's 17 of them. I mean, so you know n already, yeah.
Michael,
Do you get to work? Yeah. All right, guys. When you're done, you guys can clean up your whiteboards. You got it.
Michael, there's something in the chat.
So, yeah, we get a really big number for the total. We divide that by 17 because they should all be the same, so they all end up being like 158.8 degrees. It's okay for angles to be a decimal. It's just number of sides can't be a decimal. You can't have a decimal number of sides. So angles can be
not a whole number, but the number of sides has to be a whole number. So now we're going to talk about the exterior angles of a polygon. So if you look at this drawing here, I tried to draw the exterior angles. So what happens with an exterior angle? So first of all, you have to understand what an exterior angle is. So is if I extend my line, my polygon's line, straight out, that's considered an exterior angle. So this has 3 exterior angles. So I just extended at each vertex, I just extended in one direction. So those are the exterior angles, there's 3 of them. This is kind of a crazy rule, that regardless of the number of sides, the sum of these exterior angles is always the same. So for any polygon, so it doesn't matter if it's 3 sides or 17 sides, it's always going to add up to 360 degrees. So there's no formula for this. That the sum of the exterior angles for any polygon, 3 sides all the way up to infinite number of sides, is going to be 360 degrees. So angle 1 plus angle 2 plus angle 3 in this case would add the 360. Now this polygon has 4 exterior angles, which means it has 4 sides. Regardless of the fact that it has 4 sides and the last one has 3, those exterior angles should add up to 360. So this is the first half of this question here, and then B is a totally separate question. So we'll kind of separate them out here. So those 4 angles together should add up to 360. So we have, is that 139 plus 6x plus 9x plus 2x equals, again, 360 degrees. The sum of the exterior angles is always 360 degrees. Put these all together, that's 17x, I believe. We get 221, is that look right? Yeah. Divide by 17. So x in this case would be, I believe, 13. So you have to know the formula for the interior. The exterior is always going to equal 100, or 360, sorry. So it says find the measure of each exterior angle of a regular dodecagon. Does anyone know what a dodecagon is? 12, it is 12, very good.
Wow.
So it's 12 sides, and you can always Google that. But if I know it has 12 sides, that means it has 12 angles. The exterior angles should add up to what? 360. So if there's 12 sides, there's 12 exterior angles as well. And they're all the same. So this one's a lot more straightforward. The number of sides and angles is the same, so in order to figure out the measure of one of them, divide it by 12. So n is going to be 30. And that makes sense, you guys, because if I have a regular dodecagon, real quick before you completely ignore me and do homework. Here's my regular dodecagon. Whoa. The interior angles are huge, so the exterior angles are these tiny little 30-degree angles. So that makes sense that the angles are a really small measure because the interior angle is so large. That makes sense? So watch out for what they're asking for, interior versus exterior angles. Interior, we have the formula, exterior just adds to 360. So homework is listed there for you guys. That is due tomorrow. Sorry, you do not have AR today. You have ACP.
Alright, first Friday.